Hi, hello, hs1 students. Welcome to my next video lesson. Let's start with your homework. So this is the copy of exercise you had to do at home. I hope that it was not challenging to you because all necessary equations are given here. So let's start with gravitational force. Of course, gravitational force is mass times gravitational acceleration, which is equal to 20 newtons. Second, this net force acting on the object, F, is given by Fg times sine of the angle. Fg is calculated. Sine of 30 degrees on your use calculator is half, so 20 times half gives 10 newtons. Okay. Next, acceleration. Acceleration is g times sine of the angle, so it's 10 times sine of 30, which gives 5 meters per second squared. And finally, normal reaction force, which is given by Fg times cosine of the angle, so 20 times and cosine of 30 degrees. So let me calculate. It is 0.866, and this times 20 is equal to 17.3. Of course, newtons. I hope that your results are the same or almost the same. Again, all equations were given, so it was not challenging. Okay, so let's start a new topic. I'm going to evaluate this problem, so I need this part. This. I'm going to talk again about slope, but now let's add one more problem: frictional force. Okay, so we can write a topic: friction and slope. Or friction and slope. Nice topic. Okay, I hope you are prepared to the lesson: pen, pencil, ruler, calculator, and of course your physics notebook. Okay, first of all, as a revision, your middle school course, what the friction is. Friction is a force which opposes the motion, yes, but I hope that you remember that we have two types of friction, okay? Static friction and kinetic friction, okay? So let's start maybe with kinetic friction. Kinetic friction. Okay, what is kinetic friction? Kinetic friction occurs when two surfaces move one along another, but this motion is like a sliding, okay? When one surface slides along another. Okay, it's typical friction. You can imagine that you want to push, I don't know, a box or chair or something, and this chair moves along the floor. Then force which opposes the motion is kinetic friction. Okay? And static friction is one when two surfaces, when you have one surface which is in a direct contact with another surface. Okay, so let's imagine that you want to push a box. You apply a force, but box doesn't move because it's too heavy. Is it clear? Okay, so no motion. Okay, but watch out here, because this no motion is maybe not very precise description of static friction. Let's imagine that you are walking. Okay, so when you are walking, always one foot is at contact with the surface, so you have something like a static friction. You have no sliding. Okay, if there is no sliding, then friction is static. Oh, this is the best description. No sliding means static friction. Okay, And now something new, because mathematically friction is described by one kind of parameter which is called friction coefficient. So write point number 2, friction coefficient. Okay, what is this friction coefficient? A friction coefficient is a number which depends on the type of the surface. In general, if a surface is very flat, okay, then friction coefficient is very small. If surface is rough, then friction coefficient is very high. So each material, each surface has own friction coefficient. And mathematically, friction coefficient connects frictional force with normal reaction force. So force of friction is this friction coefficient, which has symbol of mu, like micro, but this is not micro, this is friction coefficient, times normal reaction force. Okay, so this is frictional force. This is something I'm talking about, friction coefficient. And this is normal reaction force. We was talking about normal reaction force last lesson. Okay, remember, if surface is flat, the normal reaction force is equal to the gravitational force, yes? Oh, because, do you remember last lesson we were talking about slope? Normal reaction force depends on the cosine of the angle which surface makes with a horizontal line. In this case, the angle is 0, so cosine of 0 is 1, so normal reaction force must be equal to the gravitational force. So if Fg acts down, then normal reaction force acts up, and there is the same value. So for horizontal surface, remember that Fn is equal to Fg, but only for horizontal surface. Okay, if you have a slope, something we did last time, okay, the normal reaction force, of course, is not longer equal to the gravitational force. It's related with angle. Okay, so this is gravitational force, and this is normal reaction force. If the angle is described by letter alpha, then normal reaction force is equal to Fg times cosine of the angle. So let's look. If angle is smaller, so when surface is closer and closer to the horizontal surface, okay, then for small angle, cosine is close to 1, and the normal reaction force is close to gravitational force. Okay, so remember about normal reaction force on the slope. It's not gravitational force, but gravitational force multiplied by cosine of the angle. Okay, so let's back to friction coefficient. So let's look. It's something like a coefficient of proportionality between normal reaction force and frictional force. So if friction coefficient is small, okay, and normal reaction force is small, then we have small frictional force. If friction coefficient is huge and normal reaction force is huge, then we have huge frictional force. Okay? Example of small friction coefficient, ice. Okay, ice has small friction coefficient. Example of high friction coefficient, sandpaper. Okay, sandpaper has huge friction coefficient, so it's very difficult to move surface covered by sandpaper along another surface covered by sandpaper. Okay, because friction is very high. Is that clear? Okay, so now let's try to solve something related with slope. Today I'm going to focus only on kinetic friction. So we are not talking about static friction. Static friction on the slope will be solved on my next lesson. Let's focus on kinetic friction. So point number 3, the same as the topic, friction and slope. Okay, so let's... I have this, okay. Let's imagine now again object which is placed on the slope, but we have one more force, okay, acting on the object, frictional force, which acts opposite to the direction of motion, okay. This blue force, I'm going to erase this. Yeah, at this moment I don't need this. So we have three forces acting on the object placed on the slope. Gravitational force always acts vertically downwards. Normal reaction force, which is always perpendicular to the surface, and frictional force, which acts opposite to the direction of motion. And let's assume that object slides down, okay? That friction is not too high, is not able to keep object stationary, object slides down. Okay, so now let's look. What is an overall force acting on the object? Overall force acting on the object now is reduced by this frictional force. Okay, so let's focus on these two forces. I'm going to use, let's say, a cyan color. Normal reaction force and the gravitational force. These two forces add together result in force which acts down the slope. So let's name this force which acts down the slope downward force. Downward force is a resultant force of normal reaction and gravitational force. Okay, so this Fd, downward force, resultant force of Fn and Fg. This is not overall force acting on the object, because object is also affected by frictional force. But downward force is a resultant force of Fg and Fn. Okay, and we've calculated this last time. Do you remember? If I'm going to create this triangle, so this is Fn, this is downward force, and this is gravitational force. Yes, this is Fd, this is Fg, and this is Fn. The angle of the slope is also here. We did this last time, so I'm going to mark this angle here. And you remember trigonometrical function which links Fd with Fg is related with sine of the angle, because this angle is a right angle. So sine of alpha is Fd over Fg. So Fd is Fg sine of the angle. Okay? But overall force, yes, this net force is downward, which is again, downward force minus friction gives overall force. So overall force or net force, I'm going to use symbol F, okay, is, let's look. Now we have additional force, downward force, which is a resultant force of Fn and Fg, must be, okay, we must subtract friction, which acts opposite to the direction of motion. So net force, this force which moves object down, is downward force minus friction. And this is difference between a situation when we have friction and when we have no friction on the slope. Okay? So what is this friction? Friction is, of course, friction coefficient times gravitational force. Sorry, not times gravitational force. Friction coefficient times normal reaction force, where normal reaction force is equal to Fg times, do you remember, cosine of the angle. Okay? Oof, you can copy this slide we almost finished. Okay, so finally, if you want to calculate F, you have to subtract Fd minus Ff, where Fd is here. So Fg sine alpha, and Ff is here. Oh, so mu times Fg times cosine alpha. This Fg cosine alpha is normal reaction force, and mu times normal reaction force gives friction, and of course this is our downward force. Oof, I finished. So please copy this. Next slide I'm going to give you again equations y below another, and we will do one exercise, okay? So please copy this when you will be ready. Then next slide. Okay, so the conclusion. So when you have object placed on the slope, then overall force is given by difference between downward force and frictional force, where downward force is Fg times sine of the angle, frictional force is friction coefficient times normal reaction force, where normal reaction force is given by Fg cosine of the angle, and of course Fg is given by m times g. Oof. If you want to calculate acceleration, then you can use F equals m times a, and usually if F is given, you can calculate acceleration by F over m. Is it clear? I hope that it is clear. Looks complicated, but it's logical. All equations are given, so maybe copy this also as a conclusion, last point, conclusion, point number 4. You can write point number 4, conclusion, and copy this. Okay? So let's solve something. Yeah? So write example 1. I'm going to move this to the right. Do you have this? If you don't have this, please copy this. If you have this, then continue. I'm going to move it here. I also need this. So here, and I don't need this. There. Okay. So let's imagine that we have object placed on the slope. So there's a surface slope. Okay. We have object of given mass. Yes. Use g as 10 meters per second squared. This is example 1. Yeah. So example 1. Use g as 10. Mass of the object, let's take 2 kilograms, and angle is equal to, let's say, 30 degrees. Yes, and your task is to find everything. So you have to find downward force, you have to find normal reaction force, you have to find frictional force, you have to find overall force, and you have to find acceleration. So this is complex exercise. So one by one, it's a good idea is to create all forces on the diagram. Gravitational force acting down, normal reaction force is shorter, acts perpendicular to the slope, and friction acts opposite to the direction of motion. Of course, assumption is that it moves. Okay, it slides down, and angle of the slope is here. Okay, so let's try to do this working alone. So stop video for a moment, try to do this working alone. In let's say 5 minutes, when you will finish, then you can turn video again, it will be solution. Okay, so 5 minutes later, I'm going to calculate Fg at the beginning as m times g, so 2 times 10 is equal to 20 newtons. Okay, Next I'm going to calculate downward force. Downward force is Fg times sine of the angle, which is 20 times sine of 30. Sine of 30 is half, 20 times half is 10. Okay? Next I'm going to calculate normal reaction force. Is Fg times cosine of the angle is 20 times cosine of 30, and it was 0.866 probably, and the result was 17.3, yes? Because it is the same data as you've used in your homework. So 30 cosine of 30 0.866 times 20 is 17.3. Okay, so normal reaction is 17.3 newtons. If normal reaction is given, you can calculate. I forgot about one. Sorry, friction coefficient. I didn't give you friction coefficient. So let's take friction coefficient as, let's say, 0.2. Oh, I'm going to write this as a comment to the movie. So before you will do this, I hope you will write this. Okay, so friction coefficient is 0.2. So frictional force is friction coefficient times normal reaction force. So in this case 0.2 times 17.3. Calculator, 17.3 times 0.2 is 3.46, so around 3.5. Again, 17.3 times 0.2 is 3.46. So I'm going to use 3.5, okay, of newtons. Then all is given. You can calculate overall force as a difference between downward and frictional. Yeah, remember, motion is affected by friction. So downward was 10, frictional 3.5. 10 minus 3.5 is 6.5 of newtons. And finally, acceleration of the object is F over m, which is 6.5 divided by 2, which is 3.25, yes? 3.25 meters per second squared. Oof. Looks complicated, but again, if you have equations, it's not complicated, but you must remember about these equations. Okay, so copy this solution, and next slide, your homework. Okay, the same. Yes, you have object placed on the surface. Okay, will be the same method. Object has a mass of 22 kilograms. Use G as 10. It's constant, so you can use 10. And angle of incline is given as, let's take 40 degrees. Okay, remember calculator option degree. Okay, and that's all. We have mass, we have gravitational acceleration, and we have 40 degrees as the angle. Yes, and your task is of course the same. So you can finally, the question is about acceleration, but you must do this in the form. You have to find Fg, then you have to find downward force, then normal reaction force. If normal reaction force is given, you can calculate friction. The same. Friction coefficient. Friction coefficient will be, let's take 0.3. Okay. If friction coefficient is given, you can calculate overall force, and if overall force is given, you can calculate acceleration. Okay. So remember about this. I hope you see difference between situation with friction and without friction. Please do this. You have 6 days to do this homework, but remember, you have a time to do this in your typical school time. So now, is it clear? Okay. Thank you for watching. Next lesson will be about friction, static friction, so something which stops objects. We will be talking about static friction on the slope. We'll be calculating maximum angle where object doesn't move, etc., etc., but it will be next week. So again, thank you for watching. Any comments or suggestions, write below this movie in Google Classroom. And good luck, stay at home, bye.